Hey geometry students, let's get cracking. We are dealing with 11.4, circumference and arc length. Again, I know we haven't done, I say again because I just did 11.5. I felt like doing area first, but now I'm doing circumference and arc length, doing backwards. We haven't dealt with circles. That's okay. Biggest thing that we need to understand with circles is, what is a circle? Okay, it's a line around a fixed point. Okay, it's a fixed distance from a point. So when you draw a circle, it's a fixed distance from. So we have these terms called, you already know them, okay, but I'm just go over them. That was a very poorly shaded one. Okay, so that's circle. Okay, if circle is, so if this was D, so it would be represented with like that would be the grammar for circle D. Okay, that's circle D. If the distance from the center to the outside edge is going to be the same no matter where you go, like spokes on a bicycle wheel. So this is called the radius. So R for radius. I'm going to move that over to the middle where it's a little less fuzzy. And then the distance, circumference, is walking around the circle. If I just walk around the circle, imagine this is like a real circle on the ground, and I walked around that, that's called circumference. It's not called perimeter. Perimeter's for well, you could call it perimeter, the perimeter on this fence. Okay, so perimeter and circumference are essentially the same. Perimeter is often usually like polygons and stuff like that. But we're going to have a problem later that's going to be like this and like this, and we're going to have something like that. So you're going to have a distance like this that you have plus a straight, a distance here plus this other straight. So, and we wanted to know the total perimeter. Okay. So circumference is the distance around the circle. Okay. Diameter, I should have used a different variable. So diameter is going to be the whole thing. Okay, so the formula for radius is 1/2 multiplied by the diameter. So if the diameter is 9, then the radius would be 3. Okay, so if this total distance is 9, this distance would be 3. Okay, we have this other term called pi. Okay, pi is the ratio of the circumference to the diameter. So circumference, this distance around the circle, divided by the diameter. Now, it comes out as an irrational number because it's very hard to calculate. Older mathematicians use like a 95-sided figure to try to calculate that. So could you imagine drawing like a 95 made up of a bunch of straights up here? You're just, going down, like almost like an octagon, but 95-sided figure. Very difficult, very challenging, but from that we were able to get closer and closer to the value of pi. Okay? Please use the pi key as often as you can, and keep it in terms of pi when appropriate, and we'll talk more about that. So the formula for circumference is 2 pi r. Okay, 2 multiplied by pi multiplied by r. Use the pi key in your calculator for the Texas Instrument here. You're going to have the second. It's going to be right there. Okay, so as you can see, second. That's under the second key there. So second pi, if you wanted to use it. So if I wanted to go 2, I hit second, and then I hit pi, and then there we go. Okay. So let's see. Arc length. Okay. So if I have my circle here again, the very terrible drawings here, but that's all right. So arc length. This is a circle, and we know that this is 360 degrees. All right, and say that this angle here was 120 degrees. We wanted to find arc length. Arc length is the distance of the arc. Okay. If it's a whole circle, the arc length is called a circumference. Okay, and so that's the whole distance. We want just this distance from there to there, so that is called arc length. The formula for that, so the arc length of AB, so say like I had A and B here. All right, so the arc length AB, okay, so arc length AB represented by this little symbol here, okay. Measurement of arc length AB, so that would be 120, 360 divided by 360, and whatever R is, so say R was like 3, as we mentioned earlier. So the arc length of this would be 120 degrees, divide by 360, multiplied by 2 pi times 3. Okay, so all of these out, so that's 1/3, multiplied by 6 pi, that'd be about 6.2. I guess I didn't really need my calculator because I just did that a moment ago. I mean, we could simplify that and get 1/3 multiplied by 2 multiplied by pi multiplied by 3. It'd be silly. It's just 2 pi, or decimal approximate would be 6.283. Okay. So units would be, what are the distances? So say this was feet, then it would be in feet. It's not squared, that's area. So this would be a distance value. Okay. So let's keep moving. Let's take a look at your guided practices, number 3 through 5. So it says find this. I'm going to set all these up and then come back because I'm already 6 minutes in. Okay, so I've got all the circles set up. Where's your nice happy circles, geometry teacher? Well, I have my compass in front of me, but with all the computers and the doc camp, I just can't turn my paper. I don't have enough elbow room. And then we did recycling. I could do a bottle cap, and I have a nice cool thing at school to make nice circles, but it's up to the school. So, all right. Regardless, we want to find the measurement of PQ. So we want to find this length here. All right. So always determine, are you getting diameter or radius? 9 here is not specified in your book, so we have to assume that's diameter. So then that would mean that the radius is 3. Okay. So I'm going to just plug and chug here. Measurement of angle AB is 75 degrees. Divide by 360. Multiply by 2 pi times 3. And calculating that out, that should be 5.89 yards. Okay. Okay, it's nice to have the answer in front of you. What did I do wrong, geometry students? 9 divided by 3 is 3. 9 divided by 2 is not 3. That's 4.5. Hello. So 2 pi r, 4.5. So still 75 degrees. We want to find this. That's what we're interested in. We're finding this. So 75 divided by 360, multiplied by 2 pi, and multiplied by the correct radius. All right, moving on to the next one. Circumference of this. When you see 270 like this, it's like, what is it referring to? Okay, well, that's referring to this big angle here. So you can kind of see it. That's what this is referring to. So you could find the value of this by 360 minus 270, which would allow us to find this one if we needed to. So if you ever see a 270 outside like that, that's going to refer to the big one here like that. Okay, so in the corollary, you also have this portion. Up above, I gave you the formula for arc length that's in the corollary, but you also have this proportion. Arc length divided by circumference is the measurement of the arc AB divided by 360. This one's better because you can find C. C is 2 pi r. Okay, we want circumference. So I'm just going to do cross multiplication. C multiplied by measurement AB equals 360 multiplied by arc L, okay, and then, okay, so I did the math here, so setting up the thing, doing cross multiplication. I want circumference, so I don't need to leave it as 2 pi r, I could just write circumference. That's what we wanted to find, circumference of the circle. So C, solving algebraically, gives me this equation here, plugging in the parts, 360, oh yeah, earlier I forgot to write that down, they gave us this total arc length here, this big one, okay? And so this multiplied by that there, and then we're left with 81.68 meters is the circumference, okay? That's all we have to do on that. Okay, so this next one, we want radius of the circle, and all we have is this arc length and this angle that's corresponding to the measurement of this arc here. Well, we have the formula, arc length equals, and earlier I did AB, which didn't correspond, but I changed it to EF on this one to make it match. So arc length, measurement of the arc, EF, divided by 360 equals 2 pi. We want this. So algebraically, I need to solve for this. Now you could plug in the values right now. You could go 105, boom. You could go this, boom, and do all that and crank out and solve for R. I'm actually going to do it this way because I'm crazy. I already solved for circumference earlier for the equation, and I'm just solved for that, and I know that c equals 2 pi r. You know, yeah, you could do it that way. I'm just going to say you could do it that way. I'm going to go ahead and plug in the parts. I'll stick with this way. Okay, so I plugged in the parts, 10.5 and 150, 360, 2 pi r. All right, this simplifies down to 5/6. 150 divided by 360 multiplied by 2 is 5/6. Now I'm going to divide this side by all of this, or multiply by the reciprocal of 6/5 and then divide by pi. Okay, so or you could just divide everything. Regardless, it comes out to be 4.01. I think the original feet was the original units, so 4.01 feet. All right, let's keep moving. Okay, so this is number 24, and they ask us to find the perimeter. Okay, so if we're looking at the shaded region, always the shaded region, it would be this, okay, plus this, plus this, plus this. Okay, so we know that this is a rectangle, and I don't know if they're congruent. So this is congruent to that. So two halves make a whole. This is a semicircle or half a circle. So this half plus this half. So we know that we can use the formula for circumference. So this is going to be 13 plus 13 plus 2 pi r. Okay, so 6, when it's written like that, it refers to the whole diameter. So we now need to find the radius. Radius is going to be half the distance, so that's 3. So 13 plus 13 plus 2 times pi times 3, and that answer turns out to be 44.85. They didn't provide units, so we're just going to write 44.85. Okay, so that would be the perimeter of the shaded region. So the hardest part, of course, is the curvy portion. All right, one more. Okay, so this last problem is lamenting track here. Not going to be able to watch my son run. Dear. Okay. Okay. So say we had a track. We're going to keep it in English. I love metric, but I'm just English, so that way I don't have to worry about it making it work out. Hey, we get to make a prompts. Okay. So let's say we have a track here, and we're just going to worry about somebody running on the inner track and somebody running along the outside edge. Okay. I know there's one in the middle here, but we're just worried about somebody running on the inner and somebody running along the outside. Okay. So I want to know the perimeter of the inner and the outer, and then compare the two. All right. So they're both semicircles on the ends, and the distance from there to there is 80 feet, and the distance from there to there is 120 feet. Okay. So I want to do perimeter big and perimeter. Let me change that. Let me pause and I'll set it up. Okay. So boom, a lot. So the perimeter of the outer, both of them are going to have 300 and 300. So if you're on the outer, you're running 300, you're on your straight, you run, then you hit that curve, and so then you run along this curve, and then you run along the straight, and then you run along this curve. So you're running you are running a circle. Okay, so the circumference here, or the semicircle here and semicircle there. So you are running a total circle. So 300, 300, and perimeter, a circle big. I should have wrote circumference big. Okay. So that's going to be 2 pi times 120, okay, because I said the radius of that is 120, so 2 pi r, and then 300 and 300 plus the circumference of the small, so 600 plus 2 pi 80. If you look at these, this is why it's critical when you're running in track. You know, that's why you stagger. The difference between these two is about 251.3 feet. So if you were running with someone, you know, you would run 1,353 feet, plus or minus, and they would run that many feet. So you ran an extra 251 feet by being on the outer edge the whole time. And that's why in track you stagger the starts, especially the longer the race, then the more exaggerated the stagger is. So there we go. That's all I have for today. I'll post the assignment and post this video, and you guys have a blessed day. All right.